I'm Joe, and this is Sierra Specialty Auto. Welcome to the shop. When I bought this 1979 Clark C500 forklift from the scrapyard, the seller thought that it had a cracked block. He also had this forklift, a 1952 car loader 4020, which had been in a fire. The front end was badly burned, but the back end, including the engine, appeared to be lightly damaged. Some of the hoses were still intact on the engine. Of course, some were burned. There was still some water in the radiator, antifreeze in the radiator. The block still had oily residue on it that had not burned off. So we thought that there was a good chance the engine had not been damaged in the fire. So I bought that engine too, hoping that if the Waukesha overhead valve engine in the 1979 forklift was cracked and not repairable, that I might be able to put this Continental F124 flathead engine into it. The SAE bell housing pattern appeared to be the same size, but I was able to fix the engine, the Waukesha engine. It turned out not to be cracked. It had a bad head gasket. So I got that running very well. In fact, that forklift is in great condition, and have this F124 left over, so that now the project is to see if this engine does run, and if so, does it seem to run well enough to be usable for someone else with an old Clark forklift or other piece of industrial equipment. A lot of different manufacturers bought this engine from Continental to use in a lot of different industrial and agricultural equipment. So let's head over to the engine stand, take a look at a couple of the unusual features on this engine, give it a check over, do some temporary wiring on it, and see if it'll run. This distributor cap setup is a little bit interesting. I thought I'd show this. There is some heat damage. The outside surfaces of the cap are oxidized a whole lot, and I'm not sure if all of this is due to heat. Some of it may be due to age and weathering. But instead of the typical plug-on terminals for this type of wire, it has pointed contacts. Can I get those to show? At these little points, there's one for each wire and one for the coil terminal, and the wires go onto one of the points and the point punctures the wire, and then the cap is screwed on with a pair of oval head machine screws, and that holds the wires in place. I have not seen this before, and I've looked at a lot of distributors on a lot of old engines. I think this cap is going to work for testing purposes. I don't see any cracks that go all the way through, and the inside appears to be clean and smooth. I've cleaned off the terminals here. I've set up some temporary wiring here. The points are closed. I'm running it through the original 6-volt coil, so I have added a ballast resistor to drop that. So we're running from the battery positive through the red wire to the ballast resistor, yellow wire around to the positive terminal on the coil, and negative terminal on the coil to the points and ground. So I'm going to connect the red jumper to the battery positive. I'm going to hold the plug wire to up against the head stud and open the points, and we'll see what kind of spark we get. Ouch, that's good. I'm happy with that. The coil got very hot. The internal windings are loose. If I rattle the coil, the inside windings shake back and forth. So that won't be good for to put in service. But again, for testing, it's fine. The insulation burned off of the condenser wire, but again, it's obviously working, and the lack of insulation is not having any effect. Let's get the distributor cap put back together and take this engine outside. I'll hook up the muffler to it. There's where the muffler goes. Do some jumper cable wiring for the starter, and we'll hook up some propane, see if this will go. I'm outside the shop now. I believe I have this all set up. I've got some propane run to the tank from my forklift. Got an oil pressure gauge temporarily hooked up. Here's my starter switch right here and my ignition switch over here. Right now I've got the plugs out, and I have just pumped in about 3 squirts of 30 weight oil into each cylinder. I'm going to crank it without fuel, without spark, and see, number 1, circulate oil in the cylinders, and number 2, watch for oil pressure to come up. I'll have to do something about this drainage out of the hydraulic pump. It's not quite tight. I don't care if it spits it out, but I don't want to make a big mess. Alright, we'll try again. Try to contain the mess, and this time we'll watch oil pressure. Just under 30 pounds at cranking speed. Pretty happy with that. Now I'm going to put plugs in it and open the fuel, hook up the ignition, see what happens. As soon as I turn on the fuel, I get bad leaking out of the fuel lock. The IMCO VFF 30 fuel lock. This gasket around the base is bad. I suppose it could have gotten hot enough to cook the gasket, so I will have to knock off the first start attempt right now, get this fuel lock off and get it apart and see if it can be temporarily fixed. If not, rebuild kits are available. Wes at Watch Wes work did some propane system work on one of his forklifts a year and a half or 2 years ago. He says that these are too cheap to fix. They're maybe $45 on Amazon, maybe $30 for a rebuild kit. And he's absolutely right. If I was doing this for pay, I would just buy a new one. But I'd like to take a look in here. I don't think there's a whole lot to it. So we got a Torx 27 in here. By the way, that suggests to me that this is a lot newer than the engine. I kind of think the one that originally came on that 1952 engine would have had probably Philister flathead screws, or Philister screws with a flat drive. Let's see what's in here. Some kind of deposit in here. I'm not sure what this is. There's no sign of heat damage in here. No discoloration or anything. I'm going to lap this on a piece of abrasive cloth on a flat surface. I'm going to clean this out and I think put it back together, and maybe I just needed a little more torque on those screws. We'll see what happens there. I'll be right back. Aha! Here we have a bad diaphragm. Okay, so now I go decide whether to continue the experiment here and buy a kit. Since I've already got it apart, I think probably I will do that. I've decided to go ahead and take a look at the vaporizer or regulator or converter, depending on whose website you look at. This is an IMPCO Model J, a standard part, and I already had this side out, and I looked at this diaphragm. It appears to be intact, but it also looks really rough. There's some badly aged places on the diaphragm, so I'm going to go ahead and order a rebuild kit for this. One thing Wes mentioned is that these usually are badly corroded, the housings, the metal housings. I don't see that here. These housings, they're dirty, but they're otherwise seem to be in pretty good condition. So I'm not going to worry about the housings. I think they'll be just fine. I'm going to go ahead and order the kit, and we'll save, I don't know, something like $40 on this job, which is a good thing, because this is experimental more than anything else. This is not intended to be a propane system rebuild video. It's supposed to be a first start video. Wes Johnson did a very good video on rebuilding these components a couple of years ago on his channel. I'm going to put a link to watch Wes work fixing his parts, and you can get everything you need from there better than you can get it from me. We'll set these aside. I will offer the comment. I believe Wes got his kits from the Clark dealer. I got mine off of Amazon. These are genuine IMPCO kits with genuine IMPCO parts. I wouldn't be surprised if they were half the price on Amazon. Wes didn't mention what he paid, but my guess, based on parts that I've gotten from the Clark dealer, these off of Amazon were a lot cheaper. So let's move on to the carburetor or mixer. This kit is also available, of course, but after looking at these parts in here, I decided I was going to go with the parts as they were. This is a model CA50 per the casting number. Is that going to show on there? I think probably you can see that. And it has a CA55. Well, can hardly read that now. This stick-on label was stamped with CA55. So this apparently is the 55 variation. I don't know what the difference is. The rebuild kit is the same for either of them. I'm not going to take this any farther apart. There is a mixing valve here, or I should say a fuel valve. L for lean, R for rich. This is not identified in the instruction sheet. I was able to download this online. CA55 standard carburetor mixer repair instructions. It makes no mention of this, and I don't have any technical information that refers to adjusting this. I'm guessing it's like a jet. L for lean, R for rich. It's set just about in the middle now. I'm going to leave it. I'm going to put all these original parts back in here, and I think it's going to be just fine. So let's just run through this. I'm already by the disassembly. Reassembly kit includes the air gas valve assembly, and it has a ring. It has a steel piston ring. I don't know if you can see that ring is not moving. There's the split. Maybe that'll show. Again, all of these parts are in beautiful condition. I don't see any issue with them. So we're going to place the air gas assembly in the mixer bowl, like so, and I can feel that ring. Place the spring, and this is called, here it's called the check valve plate, in the mixer bowl. That check valve plate is a snug fit over this diameter. This is the idle cutoff spring and piston. They go, put it right side up. And again, these parts look to be in excellent condition. That is going to bear on what? Okay, they want the gasket placed on the throttle body in such a way as to retain the cutoff piston under the thumb, like so. While holding the gasket and idle piston cutoff in place, turn the throttle body over. Note the cutout in the gasket to clear the check valve assembly. Okay, there's not any other way to put that on. Maybe they're talking about this. No, that's not going to clear anything. And set the pieces together. That'll be it. Line the holes up, tighten the screws. Now, before we tighten that up, the last instruction is to insert a forefinger into the carburetor air horn and lift the air valve several times, ensuring that it may move freely. And it does. I'm sure you can hear that. Maybe you can see it too. I don't know. Reinstall carburetor mixer on the engine. Set idle speed and fuel mixture to OEM's manufacturer specifications. So that'll be idle speed will be here, and this, I imagine, is the fuel mixture. that should do it for the carburetor. Before we put it back on the engine, I suppose we ought to torque the screws. 30 inch-pounds is the spec, and I do happen to have a screwdriver torque wrench. So I'll set this to 30 inch-pounds. I'm going to set the carburetor in the vise, and we'll torque these screws. And there we go. Torque to spec, 30 foot-pounds.
Right.
I have installed the newly rebuilt propane parts, the fuel lock-off and the regulator. The only thing I've done so far is put pressure to it long enough to spray soapy water around all the connections to make sure nothing's leaking. Passed that test, so now I'm going to turn the propane back on again. I've got my battery hooked up. Before I hooked up the propane, I took the plugs out, hooked them up to the plug wires, and spun the engine over long enough to see that all the plugs are getting pretty good sparks. So this crusty old distributor cap and distributor body are still apparently functional. So let's turn on the gas. I'm going to get on the other side before I hit the starter, so I'm right next to the governor in case I need to do anything with the throttle. Here's my ignition power, and here's the starter. Well, that certainly worked out well. That sounds pretty darn good. Doesn't seem to blow a whole lot of smoke. It certainly fired right up. I'm really happy with that. Now I believe I'm going to hook up the radiator temporarily so I can run it for 15 or 20 minutes, let it warm up fully to operating temperature one time. And then I'll do compression test and see how good the compression is. Oh, how nice is that? 40 pounds of oil pressure at idle. I did have the radiator over full, so it is shedding a little water now that it's shut down. I didn't want to run that hydraulic pump any longer. I think it's okay for a little while. There's enough oil in it to keep the gears lubricated. but I didn't want to push that too much. We came up to 190 degrees, and then it dropped to about 185, indicating that the thermostat opened. I shot some temperatures with the Raytech gun and got well under 200. Except on the exhaust side, I got down in the 170 range, shooting the block all the way around. Water going into the radiator was showing about 170. So I think that has checked out very well for an old Continental. It's very quiet. Previously, when I listened to the engine on the video, it sounded much better in person than it did on the video. The audio on the camera obviously picks up some kind of harmonics or something that makes it sound worse than it is, and I've heard other people say that on engine videos. So I'm going to call this a 100% success on this startup. I'm just really happy with the way it runs, with the way it sounds, with the oil pressure, and maintaining temperature. This is going to be a very good engine for somebody to put in a forklift or other piece of industrial equipment. All right, I am happy with the way that turned out. That engine does run quite well and quite quietly. I got compression numbers of 95, 90, 90, and 95 on 1 through 4 respectively. So that's not a factory fresh engine by any means, but the numbers are very uniform, and along with the 40 pounds of oil pressure indicates that there is life left in this engine. So it is worth putting on the market, I think. Thank you for watching. I appreciate it.